In this video, I want to talk about unique pointers and polymorphism. Now, in the polymorphism lesson, I talked about how useful it can be to have a pointer to some base or abstract class, and then store the address of some heap object, which is a derived class, in that pointer, because now you can do all sorts of things, and the appropriate function, that is the member function of the object that is on the heap, will get invoked. You could do all sorts of things. For example, you can have a reference to a base class constant, that is for the formal parameter of some function, and then you can pass a base or a derived class into that as an argument, and again the appropriate function will get invoked. That is in the case where we have virtual member functions which enable polymorphism. Now, if you think about this for a second, let's say you have some unique pointer that manages a pointer of type base or some abstract class, then you can initialize it to some concrete class or reset it to some other concrete class later on. As a simple example, I'm just going to include the memory file again for the smart pointers. Then I have a base class with a virtual destructor, and then we also have some virtual toString function which is going to print out base toString, and the same for the derived class. This is going to publicly derive from the base class. It has a virtual destructor and it has a virtual toString function as well, which we override of course from the base class, and this will print out derived toString in this case. So in the main function, let's go and create a unique pointer that manages a type of base. But with the makeUnique, we're actually going to pass in a type of derived. I'll just call it UPTR for unique pointer, of course, and then I'll do the toString function on that. So let's see what we get. We should get the derived version printed out. And as you can see, that's what we get. We get the derived version printed out. It's going to allocate both parts of that derived object. That derived object consists of parts derived and base. This will work with base too, because base in this example is not abstract. Build around that, and you'll see that works with base toString now. I'll just undo once. If we remove the virtual keywords, and I'll remove the override as well, because if we leave that, then we'll get an error. I'll just delete this here. Override does not override the base class member. That's because toString is not virtual in the base class. Back in main, if I construct our unique pointer to be of this type, so unique pointer and I pass in base, and then I use makeUnique and I pass in derived, this will now print out the base version of the toString function, because the managed pointer is going to be base even though the object is going to be derived. Build around that. Base toString, and it also won't call the correct destructor. So I'll just go and make the destructors virtual. Now if we build a run, we get the derived destructor invoked, and we'll also clean up the base part of course, but it still just prints out base toString. Again, I'll make that function virtual. And so again, we enable polymorphism by using the virtual keyword. Build a run, and this will now work fine as we would expect. As I mentioned, we can also use the reset function here, so with the initialization, I'll use makeUnique and I'll pass in the type of derived. The object on the heap is actually going to be of type derived, so in the statement right here I do reset, which will deallocate the derived object on the heap, but I also allocate a new base object on the heap. I'll call the toString twice, so we get derived toString now, and then the derived destructor is going to get invoked, because we do the reset function, which is going to deallocate that heap object, and then we call the base destructor as well, because that is going to deallocate the base part of the derived object. Now in that reset function call, we also allocate a new base object on the heap, and then we do the toString right here in the next statement. So with that member function invocation, we also get the base toString printed out, and then we get the end of the program. The unique pointer is going to go out of scope and it's going to clean up the heap object that it manages, which in this case is a base object, so we get base destructor invoked. In this next example, I have an abstract and a concrete class. Concrete is going to publicly derive from the abstract class. Both the abstract and the concrete class has a destructor which will print out a relevant string. The abstract class also has this pure virtual toString function, which gets overridden in the derived concrete class, or implemented in the concrete class, so that we can actually instantiate the concrete class, and the implemented toString function in the concrete class prints out an appropriate string. Okay, now back in main, I construct this UPTR for unique pointer again, which is a unique pointer, and I pass in abstract. Then I use the makeUnique and I pass in concrete, and I do unique pointer toString again. If we build and run, we get concrete toString, and then we also get the appropriate destructor invoked. Now this is basically the same as doing this. Okay, this is a unique pointer that manages an abstract pointer, but in this case the object on the heap that is going to manage is actually a concrete class. Build and run and we get the same output. I'll undo that because we want to use make unique here. Again, the goal with smart pointers is to avoid using the new and the delete operators. Now as a final demo, let's look at a function again. So I'll go and create a global function, some print or display function. As a formal parameter, this is going to have a reference to a unique pointer with an abstract pointer that it will manage, constant. Okay, in this display function, the unique pointer parameter is a reference to a unique pointer. I pass an abstract, and then this is const as well. So if that is not a null pointer, then we do the toString. Okay, back in main. I'll invoke the display function and I'll pass in this unique pointer as an argument. Build around that and let's see what we get. We print out concrete toString twice and then we get the destructor invocation. Also, if you remember, the display function has a formal parameter now of reference to unique pointer abstract constant. So what we can do is we can pass in something like this. Make unique concrete. Build around it will do the toString for the unique pointer. Then it will construct the temporary object and we'll get the destructor invoked for that following the concrete toString for that. And then following the end of the program, we'll get the concrete destructor invoked again. Of course, if you try and instantiate the abstract class, you'll get an error. Okay, if you try and do something like that, you'll get an error. So Control B to try and build that. And you'll get a failed. Cannot instantiate abstract class. And the same thing here. Control B to build. And you'll get that same failed as well. Okay, I'm going to leave it here for these demonstrations. I hope you found this interesting and I'll see you next time.